Howdy and welcome to the second part of our Introduction to Database presentation for CIS 3107, Database Modeling. We'll be covering sections 1.4 through 1.6, which correspond to pages 11 through 21 in our text. In this second presentation, you will learn why database design is so important. Databases evolved from computer file systems. Although file system data management is now largely outmoded, understanding the characteristics of file systems is important because file systems are the source of serious data management limitations. A problem that has evolved with the use of personal productivity tools such as spreadsheets and desktop database programs is that users typically lack proper data modeling and database design skills. People naturally have a narrow view of the data in their environment. Database design refers to the activities focused on the design of the database structure that will be used to store and manage end-user data. A database that meets all user requirements does not just happen. Its structure must be designed carefully to facilitate data management and generate accurate and valuable information. In fact, database design is such a crucial aspect of working with databases that most of this course is dedicated to the development of good database design techniques. Even a good DBMS will perform poorly with a badly designed database, which cause difficult to trace errors. To be successful, an organization must develop systems for handling core business tasks. Historically, such systems were often manual, paper and pencil systems. The papers within these systems were organized to facilitate the expected use of the data. As organizations grew and as reporting requirements became more complex, keeping track and generating reports from manual file systems was slow and cumbersome. Therefore, a data processing (DP) specialist was hired to create a computer-based system that would track data and produce required reports. The end user's desire for direct hands-on access to data helped to fuel the adoption of personal computers, spreadsheet programs, to allow the users to enter data in a series of rows and columns in order to manipulate data with various functions. The description of computer files requires a specialized vocabulary. Every discipline develops its own terminology to enable its practitioners to communicate clearly. Data are raw facts from which the required information is derived. Data has little meaning unless they are grouped in a logical manner. Field is a character or a group of characters, numeric or alphanumeric, that describes a specific characteristics. A field may define a telephone number, a date, or other specific characteristics that the end user wants to keep track of. Record is a logical connected set of one or more fields that describes a person, place, event, or thing. As more and more computerized files were developed, the problems with a simple file system became apparent. The problems basically centered on having many data files that contained related, often overlapping, data with no means of controlling or managing the data consistently across all the files. As shown here in Figure 1.8, each file in the system used its own application program to store, retrieve, and modify data. Also, each file is owned by the individual or the department that commissioned its creation. The problems associated with a file system severely challenge the types of information that can be created from the data, as well as the accuracy of the information due to the lengthy development times. The difficulty of getting quick answers, a more complex system administration, the lack of security and limited data sharing, and the extensive programming often required. Understanding the shortcomings of the file system enables you to understand the development of modern databases. Although many of these problems are not unique to file systems, failure to understand such problems is likely to lead to their duplication in a database environment, even though database technology makes it easy to avoid them. A file system exhibits structural dependency, which means that an access to a file is dependent on its structure. When file system application programs are affected by changes in the file structure, they exhibit structural dependency. Conversely, structural independence exists when you can change the file structure without affecting the application's ability to access the data. Data independence is a condition in which the programs that access data are dependent on the data storage characteristics of the data. Systems that lack data independence are said to exhibit data dependence. File systems exhibit a data dependence because file access is dependent on a file's data characteristics. Therefore, anytime the file data characteristics are changed, the program that accesses the data within those files must be modified. In contrast, data independence exists when changes in the data characteristics do not require changes in the programs that access those data. File systems lack data independence because all data access programs are subject to change when any of the file system's data storage characteristics, such as changing a data type, change. Data redundancy exists when unnecessarily duplicated data are found in the database. For example, a customer's telephone number may be found in customer file, in the sales agent file, and in the invoice file. Data redundancy is symptomatic of a computer file system, given its inability to represent and manage data relationships. When end users create their own private copies of the data, which creates issues of data ownership. This situation also creates islands of information, where changes to one set of data are not reflected in all the copies of the data. Uncontrolled data redundancy sets the stage for poor data security, lack of data consistency, and increased likelihood of data entry and integrity errors. Because the data in various files may be intended to represent a view of the business environment, a lack of consistency in the data may lead to faulty decision-making based on inaccurate data. The dictionary defines anomaly as an abnormality. A data anomaly takes place when inconsistent changes have been made to a database. For example, an employee moves, but the address change is not corrected in all the files in the database. Updated anomalies, insertion anomalies, deletion anomalies are the different subtypes of data anomalies. On a positive note, however, this course will help you develop the skills needed to design and model a successful database that avoids these problems. In summary, databases evolve from manual and then computerized file systems. In a file system, data is stored in independent files, each requiring its own data management programs. Although this method of data management is largely outmoded, understanding its characteristics makes database design easier to comprehend. Some limitations of file system data management are that it requires extensive programming, system administration can be complex and difficult, making the changes to existing structures is difficult, and security features are likely to be inadequate. Also, independent files tend to contain redundant data, leading to problems of structural and data dependency. Thank you for watching our Unit 1 Part 2 presentation. The diagrams and content of this lecture were derived from your textbook. For more detailed discussion of these concepts, please review pages 11 to 20 in your text.